But for the UK, hydrogen has the capability of being stored. So once it's generated, it can be stored, and it's there to use as and when you wish, rather than needing those megawatts on demand through an electric network. So I think they're complementary. There are some challenges between both, but hydrogen will help deliver decarbonisation.
And if it's going to be promoted, Dennis, what's the role of government in doing that?
It's significant in the same way that we've already seen the move that recognises that the CO2 emissions and the like from the passenger car sector and the light duty sector needs to be phased out in order to meet those 2050 targets. You start and look at what you need to do for the buses. That's in discussion, and then into freight vehicles and in particular the heavy duty vehicles. What that's going to look like, the how and the when, and what you need to help facilitate the drive, capital support for the vehicles, probably more capital than operational support. And then you've got to start thinking about how you will, not necessarily parallel, but how you would facilitate the first initiation of the hydrogen refueling stations, whether they're at back to base for truck fleets or supported with public refueling stations. That's a mix that you need to be able to work with as well. So that's all part of the decarbonisation of, as I say, the heavier duty sector or the more intensively utilised vehicle sector for the UK.
Of course, got to have government involved in the initial production of hydrogen in the greenest way possible, I guess.
And government's already starting to step up to that. So the industrialisation strategy and the need to be able to deliver large quantities of hydrogen to help decarbonise heavy industry itself is part of that. Start and look then at how you use those clusters and hubs to be able to start and build out from there, and then create intermediary support. And if you, the point already made by Philip just recently, heat and decarbonisation of heat. If you are putting hydrogen into gas pipelines, there are technologies that allow you to help get that out, clean it and use it for transport purposes as well. People are already working on that technology now. That means that hydrogen becomes a much more ubiquitous commodity fuel.
And what about digital technology, the role that it plays, both in sustainability, but also kind of more widely in the objective of providing a decent consumer experience?
Absolutely. So digital technologies is going to be the cornerstone in the EV ecosystem, the entire EV electric vehicle ecosystem, right from the buying experience to the charging and to even the disposition, right? So, I'm going to speak to the experience that we had in creating the charging infrastructure for 40 cities across India, right? So, we have cloud where you need to create charge management system, subscription management, and onboard partners to be able to give a seamless experience to customers. Because of all these things, charging anxiety is going to be the major inhibitor for the growth of EVs, okay, despite the incentives from the various agencies. So therefore, cloud plays a major role. And like I said, data and the artificial intelligence going to be extremely important, because in order to understand the charging and alleviate the charging anxiety, we need to know the customer behavior more than ever. So we all know we are talking of two industry segments, automotive and utilities. And even within utilities, the amount of data and how we share the data has a long way to go. So therefore, it's important to get the data to understand the customer behavior, the lifestyle, home charging, out of home charging, etc., to provide the seamless customer experience. And more importantly, third one, which is this is going to be a huge technology. I believe personally this is going to be a huge uptake in the technology blockchain, right? Because today in the charging ecosystem, we have too many players, right? Independent charge operators, automotive OEMs, then energy companies, oil and gas companies coming into this. So when there are, and even the consumers who are going to be playing a major role when it comes to smart charging. So therefore, there needs to be a trust among those ecosystem players, and there needs to be an element of peer-to-peer transaction as well. So I think technologies like blockchain, cloud, automation, AI and machine learning is going to play a very important role in enabling this EV charging ecosystem.
If you've got a motor park full of plug-in vehicles, Philip, just to follow on from what Anandh was saying, I mean, is the silver bullet smart charging?
Smart charging is without doubt going to be a really important mitigant, right? A way of reducing the cost and improving the consumer experience, I think, of the transition. What you talked earlier about the blurring of the lines, the most apparent thing is that, the battery in a car is a part of the energy system in a way that the fuel tank has never been a part of the oil sector. There is an interconnection between the operation of the two that can serve to their sort of mutual benefit and advantage. If we're able to encourage people to charge smartly, it has a number of benefits. First of all, by reducing the peak demand on the system, it means that networks like Ian's need to invest less in reinforcing the local grid. So it saves money at a whole system level. Secondly, it means that the users of the vehicles are likely to benefit from lower tariffs because they'll be incentivized to charge at a time when the cost for the system is low, and they'll be able to, and they have the option to avoid paying really expensive costs. So it means a better consumer outcome from that point of view. So the advantages of smart charging are real, and I think they're important, and we have to do all that we can to try and make that as seamless an experience for car drivers.
Tim, under what conditions, if I could put it like that, would your customers take up smart charging? I mean, what is the thing that gets them there?
I think the concern that some would have is about the perceptions that a customer might not be able to charge when they needed to. And I think the opportunity with smart charging is that if we have knowledge of things like a customer's departure time, for example, which OEMs would generally have from the vehicle, then it's possible to manage the charging in such a way that the vehicle is charged at some time overnight. The customer doesn't really necessarily know when it was actually charged. As long as it has the right amount of charge by next use, then there's an opportunity there for the customer not to have to worry about it, and somebody else to manage all of this in a way that delivers value to the customer in the lowest energy cost, lowest CO2, etc., etc.
So, I mean, following on from that, what if I could put this to you, perhaps, Ian, what are the initiatives that UK power networks have been pursuing when it comes to smart charging and low voltage flexibility? What direction have you been going in?
Yeah, I think just picking up on Phil's point there about is smart charging and flexibility the silver bullet? Definitely it has a huge place to play, and I see it as what I call a insurance cover as you build various blocks of need as things like EVs come on, heat, etc., so that you don't invest unnecessarily. And that's how we see it at UKPN, and we've been working in collaboration with many of as Anandh said, many of the actors in the system at the moment, trying to work out the right products where we could come together and say, mix it up with a wholesale cost. Can we put some of the distribution use of system cost, and can we flex that to help customers move their charging need? And actually what we've realized through a project called Shift is between 60 and 80% of customers will move their habits away from the peak of the network in the evening. Great learning. We're learning other things like we'll create other peaks in the morning that are maybe bigger than the peaks that were in the evening in the first place. So, but that's all part of this learning, is how do we all come together to understand how that part-time transport asset can play a part-time energy asset in the same way. And that's not just when it charges, but actually when it discharges as well. So you consider that energy should be able to flow any which way in the distribution network. And that's what we're trying to get ourselves ready for.
Yeah, and that's the kind of the end point, isn't it, Ian? I mean, we've heard it again and again actually during the course of the day, and we've just heard it again. This idea that when we're talking about battery technology, when we're talking about EVs, when we're talking about this entire infrastructure, we're talking now about a kind of two-way street, actually, where everything is plugged into everything, and that's the future that we've got to convince people that they're going to be part of.
Yeah, absolutely. It's called connected systems, right? What you have is two independent systems, which strangely enough, most of the time ran next to each other or within each other, cables in roads, tower lines next to motorways, very rarely really got together. And we now start to see that. We have basic examples how the rail network can become a charging network whilst the cars are static. So we've got to move our mindset from a traditional model of systems running independently to actually how do they coexist? Gas, electric with heating, et cetera, et cetera. That's where the value lies. So it's about how we do that in an incremental, lowest cost, fastest way. Is because pace. Before we started the session, just the group were talking about how fast this is. Just the EV revolution has moved in the last 5 years, and I expect that will gain pace. So our traditional models of taking many, many years to build infrastructure and holding this up is not an option for networks. It's about creating the products that buy us the coverage whilst we do the things that we need for the end game.
Let's go straight to questions that we have from people who are watching. And Jack Huntsley from Automotive World asks this. It's actually a question for you, Tim, I think, and it's this. How prepared is the UK's charging infrastructure and energy sector compared to the likes of Germany, France, the Netherlands, Norway, etc.? What role can automakers like Ford play in getting these elements up to standard? Tim.
Okay, so I think one of the big areas I would separate the UK from most of the other countries mentioned, with the exception of Norway, is about providing ease of access to charging equipment. Fortunately, in the UK, we have a historical model where you effectively need an account with each charge point operator, and that becomes arduous with a pocket full of RFID cards or a phone full of apps. You have to use multiple apps to plan your journeys and all the rest of it. And I think part of the value that we can bring as OEMs is to draw all that together for customers so that we can integrate and we can offer people access to many networks through the convenience of the vehicle, so that we take away that major pain point for customers in actually learning about charging, finding compatible chargers. So, for example, in our vehicles, we have live charge point availability. We will very shortly have the ability to pay from the vehicle for the charging. We only show you connectors that your vehicle is compatible with. When you go on a long journey, we will filter out the slow chargers and only show you the fastest chargers to enable you to do your long journey. Whereas if you're looking for somewhere near your home to charge, we'll show you the AC ones because you may well want to leave the vehicle overnight. So we can do a lot to ease things for customers in making this transition from petrol or a diesel into a fully electric vehicle.
Right. Another question from Alan Hutchison from Oxford Brookes University, and it's to you, Ian. The vision of shared energy and vehicle to grid is desirable in the future. Is it realistic, though? Is it realistic for individual vehicle owners? What's the hardware cost for an individual owner?
Yeah, it's a good point, to be fair. And probably give you a good stat is on Christmas Day, I cooked our turkey on my Nissan Leaf. So I stored all the energy and I used my vehicle to grid charger to export and cook almost the whole day. I got off the family around. So it's a reality. It's today you can do it, but bang on, it's the commercial case about the technology in terms of the charger. And there's been some great steps. I remember we put projects together two and a half years ago where a vehicle to grid charger was about £8,000. What was available in the market was, I think, a product called Nishikon. The product I have on my wall outside is now a wall box charger, and that's come all the way down to £2,000-3,000, and that technology will keep reducing over time as the value of that asset, as people start to see that value of that asset as not a car, but actually an energy storage asset that when it's not moving has value that can pass back to the system without interrupting that customer's life. So definitely, I think there's great legs. We've got 4 projects. We're doing it with buses as well. So we've got a project with bus to grid to say, when that asset is stagnant, could we use that to really leverage value back to the customer or the owner of that asset?
For Dennis, I think it's from Richard Green from TechNX. What's your view on the likely uptake of hydrogen fuel cell versus hydrogen combustion in commercial vehicles?
There's no question there's quite a lot of hydrogen combustion that's being trialed and used at the moment. Certainly some of the heavy duty vehicles are working on hydrogen combustion rather than with fuel cell. And that's good in the sense that it gives you certainly a lower carbon footprint, but it still has NOx and a small amount of particulates, and it's not zero emission in that sense. So you've got to look at where you want to go. It's a transition pathway, but ultimately, if you need to meet net zero targets, then you're going to move into the fuel cell. And the point about the sort of the ability of hydrogen to be able to give you a zero tailpipe outcome and the sort of the energy density in the fuel that you have on board, you will be able to meet a full duty cycle with the hydrogen, and in the same way that you would be able to blend diesel with hydrogen or just run on straight hydrogen combustion. So it's a pathway. It's not the only solution.
Here's an interesting question from Greg Scott from Kia Motors. For all of you, maybe I'll put this to you, Philip. Do you think at some point the government might force, by taxation or by law, public access to home charge points already installed to improve the network availability?
So I obviously can't speak for the government. I would be very surprised if we were to go to the point of forcing people to make services like this available. There are already technologies that are being developed and offers that are being put out there by some of the more innovative companies that give people who have got home charging the option to make that available to others, whether it's people who are visiting them or indeed, you know, their neighbours who might not have access to off-street charging of their own. That, I think, is fantastic. I think that's something that we should really value, and I think it's all part of this exciting world of evolving new offers and propositions that Ian was talking to earlier on. And I'm not sure that it needs to be forced. If you know, if there's something that's attractive and appealing both to the person who's got the charger because they're able to get more revenue and the person who needs the charge because it's convenient, then the technology is emerging to make it happen. And so we should just welcome it and let them get on with it.
And what's your view of that the kind of sharing economy when it comes to charging stations?
Yeah, so I think, you know, let's consider this fact, right? 1/3 of the UK homes don't have a dedicated car park for their homes, right? It is all street parking. Now, it is important that the accessibility of the charging, whether it is home or office or out of home network, needs to be there for frictionless experience. So therefore, it is important to have that accessibility of the charging networks and the charge points in various areas. More than the government, I think many retail companies, for example, are setting up charging infrastructures to enhance their footfall on the business. So I think the economics and the dynamics, like Phil said, the buying and selling of the charges of whom need of them is going to balance out, and technology is going to be a key enabler on that, like I said before.
A question from David Price from Daft Trucks. I think this is for you in specifically. Are you aware of any plans for a public network of chargers for commercial vehicles above 7.5 tons?
No, I'm not aware. To be fair, and the modelling we've done is been bang on to what Dennis said. Is we don't believe battery heavy good vehicles is the right solution for the UK, and it's not something that we are actively trialing on innovation, because we believe there's other technology like hydrogen. Overhead catenary systems are another option which may better serve that sector.
The whole question of, we were getting quite a few questions about hydrogen for heavy vehicle duty use. I mean, a kind of broad question, which anyone could come in on. Does the government, do you think, understand properly that is the way forward for heavy vehicles, and for particularly those involving long distance? And is there the right amount of thinking behind the scenes on that? Well, I suppose, possibly for you, Dennis?
Certainly, I'm happy to start that, because the government is looking at the heavy goods sector, and certainly recognising that heavy-duty freight, buses, rail, and and marine are all on their radar at the moment. And of course, it's also looking at fuel cells and hydrogen for aviation. So it's a longer term, but it is a transition pathway that is going to go across all of those sectors. Near to medium term, it's around buses and trucks and urban distribution vehicles, because that's where you start and get the best advantage out of going to zero tailpipe emission, and then utilising the development of hydrogen that's coming into the networks as availability as a transport fuel. So those assessments are starting. The Bus Back Better program is already looking at what you need to do in terms of the proportion of fuel cell and hydrogen buses as opposed to battery electric, and that's to a large extent the difference between what you would have with a 12-metre double deck urban route, rural route, and so on. There are going to be natural selections where the hydrogen is most effective. The others we're still waiting to see. So it's more a matter of trying to understand which parts you prioritise, and certainly near to medium term, I would say that is probably 12-ton truck up to 21, 26-ton truck, and perhaps urban refuse collection and special type vehicles that you could prioritise in order to get the best out of the net zero side of the operations.
Following on from that, Dennis, I had another question, an interesting question, that if we are increasingly talking about hydrogen in heavy-duty vehicles, is there likely to be a kind of trickle-down effect where we become more interested, governments become more interested in fuel cell car adoption?
Well, certainly fuel cell cars, the Toyotas, Hyundais, and other car makers of this world, and certainly in China at the moment, are still making fuel cells a passenger vehicle segment capability, and are investing significantly in doing that. So it certainly starts to address some of the question about, well, how many hydrogen refueling stations do you need? And how do you do that cost effectively? It's volume, it's scale. Fuel cells hydrogen are quite capable of scaling up, and the initial work that was done for the UK H2 Mobility Programme and looking at passenger vehicle sectors foresaw that the UK could potentially have well over 1 million hydrogen fuel cell passenger vehicles, and needing around a couple of thousand refueling stations to meet national requirement, and growing way into much larger fleet numbers over time. So you move on to those that need it soonest, and then you can backfill into those other segments to make it a more viable proposition. Scale, investment in the manufacturing of the fuel cells and the vehicles is also something that the UK needs to be looking at as well.
Sorry, could I just add something from an energy systems point of view on this? Yeah. So that hydrogen is going to play a critically important role in enabling the UK to get to net zero is absolutely understood. By 2050, we estimate that we'll need to have created a hydrogen economy that is as big as the total electrical economy is today in the UK. But we're doing it from a standing start, and every one of those molecules must be completely net zero for it to have a meaningful impact on the targets that we're talking about. So I would just urge us to be patient when we're thinking about the emergence of the hydrogen economy. It's going to take a while for the supply capacity to grow. And there are so many divergent calls on the use of hydrogen to decarbonize different parts of the UK economy that there is going to be quite significant competition for it. Quite where transport, and particularly light-duty transport, would fit in the merit order compared with all the other potential applications for hydrogen, is something that, as Dennis was pointing to, will emerge over time. But with thinking about the 2030 targets in mind, I'd be really surprised if we've got meaningful amounts of hydrogen available to use as a transport fuel for light-duty cars in particular.
Okay, a question that I think probably is best put to you, Ian. It's from Scott Bradley from Auto Trader. Should new building developments have three-phase electricity supplies fitted as standard as we're gearing towards net zero?
Yeah, absolutely. The challenge of the UK network historically, it was a single-phase domestic network. So when you've got a three-phase cable in the street, but everybody's teed off one of the phases. When people talk about a three-phase network, it's that last 5-10 meters to your home. We should make that three-phase, most definitely. And there's various benefits of doing that. You get an opportunity to balance the network. In other words, you can use the three wires equally along that network so that you can get more out of the existing network. So that it'll be more efficient. And if you look at networks in Norway, those types of networks are more susceptible to carry larger volumes quicker than our UK network. And those are programs that we, as electricity networks, are now starting to roll out as part of refurbishment programs as well. So that when we go back to those networks, we're going to put in a three-phase little supply to the home at the first opportunity. Because the marginal cost is 85% of the cost is digging rather than the actual copper or the cable asset.
Look, thank you all very much.